Hi everyone, Jim from Javelin here with a SOLIDWORKS tech tip. I'm going to create a socket head cap screw for the purposes of 3D printing. So I'm going to go in here, I'm going to right click on it and say create part. So there's the part right there. It's going to be M6. Let's make it 12 millimeters long. Now if I look down here under thread display, I have a couple of different options. If I choose simplified, then it just ends up, it's going to print out a pin, which obviously isn't going to thread into anything. If I say cosmetic, it looks kind of neat, but unfortunately all it is it's just this surface is striped. You can see if I look at the edge here, it's still a straight edge. So when I go to 3D print this, it's still going to be a pin. If I change my thread display to schematic, that's done something to my edge. But if I take a closer look, all of these are parallel to my front face. It's not really threaded. It's just sort of a representation of a threaded part. So this obviously won't thread into anything. So let's go back to simplified, and I'll click OK. Now that it's been configured, what I want to do is I want to start making changes, but before I do that, I don't want to actually change my toolbox part. I want to save this to a different location. So I'm going to go File, Save As, and we'll just save it on the desktop as part for 3D printing. Save it. Okay. Now that I've done that, I'm going to cut my threads into it now. But actually, before I do that, I want to remove that pesky toolbox flag. I'm going to close the part, and I'm going to go to my installation folder, see Program Files SOLIDWORKS Corp, and then there should be a subfolder under there called SOLIDWORKS, and then Toolbox, and then there's another one called Data Utilities. And in there you'll find a little utility called SLD Set Dock Prop. I'm going to run this. We're going to add files to this. And I'm going to go in and find this part for 3D printing, and I'm going to choose No. This is going to turn off the toolbox flag so that when I use this in an assembly, it's not going to say, hey, this is a toolbox part, let's open it from the toolbox instead. Neat little trick. Okay, so let's open up the file. There it is. So now to the meat and potatoes of what this blog article is about. I want to create a thread. So what I'll start out by doing is I'll start out by creating a sketch for my profile. Now, typically I would get something like this from a machinery handbook, but I'm just going to make up some values for this if you don't mind. If you have any objections, feel free to share them right now. Okay, so I'm going to add some dimensions here. And the other one I want. Ah, yes. I'll make the width, let's make it 0.9. And finally I'll position it roughly here. There we go. So now my sketch is fully defined. Rebuild out of that. Okay, so the next thing I'm going to do is I'm going to create my path sketch. So for this, I'm going to create a helix. So to create a helix, first I'm going to create a circle. I've used convert entities in order to convert my existing circle to ensure that it's the same size. It doesn't actually need to be the same size though. It just makes it easier to see what's going on if it is. So now I go to Insert, Curve, Helix Spiral, select my circle, and I can input my parameters. In this case I want height and pitch. So my height is going to be 12 because that's the length of the threaded section. And the pitch is going to be 1 because it's M6 by 1. I'm going to pay some close attention to my start angle because I want this to start on my sketch plane. There we go. You can see it starts on my sketch plane, which means that this is going to behave in a predictable manner. As a side note, if this starts not on my sketch plane, then what ends up happening is that my sketch will start there and it'll go this way, but it'll also backtrack up 355 degrees back to this point up here, at which point it'll be up here in space. Okay, so I have my my helix. And now I'm going to insert my swept cut. So I'm going to go to Features, Swept Cut, and I'm going to use a swept cut with this profile, and this as my path. Click OK. And now you can see I have a threaded fastener, at least until it gets down to the bottom. You'll notice that it becomes flat down here. If I'm 3D printing this, it's not going to be a problem. Oops, I don't want to use that plane. What we found through some testing here at Javelin is that if we're 3D printing something, it's best to model up something that's roughly, maybe slightly oversized, and then run it through a tap and die set in order to get the threads on there so that they'll fit properly. The last thing I'm going to do is I'm going to add an undercut. Just in case you're doing this for aesthetics. Oops, that's not enough. It's probably a bit too much, but that's okay. And now I can do a revolved cut. And now I have my undercut.